Okay, so this is still for the midterm review part 1. I've accidentally hit a button on my iPad during the last video and it stopped recording. So I'm just picking back up where I was on number 9 here on the midterm review part 1. So if you haven't watched that first part of the video, you should watch that video first. But number 9, we were getting into complex numbers, which is in section 1.8. So there will be a few problems on your midterm with arithmetic of complex numbers, or imaginary numbers. So first of all, one thing to note is that the general standard form of a complex number is a plus bi, which means that the real part, the real number, always has to go first, and then the imaginary part, which is the b times I, always is written second. So you always need to write your answers in this form. This is complex number form. So a couple examples of that would be like 3 plus 2i, or 5 minus 6i. You could even, complex numbers are also, they could just have the imaginary part, like 4i. So you would just write it like that. But these are some examples that are in complex form. So you just don't want to write the part that has the I in it first. You always want to write that second in your answers. All right, so let me erase this so I can have some room. Okay, so on this problem, we're just adding two complex numbers together. The first one is 3 minus 16i, and then minus 2 minus 5i. So I guess technically we're subtracting them. So because that negative is in front of this parentheses here, we need to distribute that negative to both of these terms behind it. So I'm going to rewrite this as 3 minus 16i, just bringing that down. This would be minus 2, and then negative and a negative makes a positive 5i. So that's just distributing the negative. And now we're just going to combine like terms. So I have 3 minus 2, which is 1. And negative 16i plus 5i, even though those are imaginary numbers, we can combine them normally like terms. So negative 16 plus 5 will give us negative 11. So this would be negative 11i after combining those two like terms. And that's it. This would be the final answer to this problem. This is in complex number form, and there's nothing else I can do to combine them. Okay, number 10, still in section 1.8 here. Now we're going to be multiplying two complex numbers together. And because the complex number is made up of two terms, this is a binomial times a binomial, so we're going to FOIL to multiply this. FOIL stands for first, outer, inner, last, when you multiply two binomials. So first means we're going to multiply the first two terms, 2 times 8. Outer means we're going to multiply the outside terms that are on the edges of this whole expression. So that's 2 times positive I, which is a positive 2i. So this would just be plus 2i. Inner would be the inside terms. So negative 5i times 8. I'll just write it like this for now. And then last would be the last terms of both of these binomials. So that would be negative 5i times I. So this was my first, outer, inner, last. Let me write that in a color actually above it. All right, and now we will actually do this multiplication. So 2 times 8 is 16. Bring down the plus 2i. Negative 5i times 8 will give us negative 40i. And negative 5i times I will give us negative 5i squared. So now we're going to combine like terms. So we have 2i minus 40i in the middle there. That'll give us negative 38i. Bring everything else down. And then another thing about complex numbers, and you can write this on your flashcard for the exam, is that you need to be aware what I squared is equal to. So first of all, the definition of I, an imaginary number, is the square root of negative 1. We kind of already talked about that in the last video. So if I squared both of those sides, squaring a square root cancels that operation, and that would just leave you with negative 1. So I squared is equal to negative 1. So you can have this on your flashcard. Anytime you see I squared in a problem, you need to replace that with negative 1, because that's what I squared is equal to. So this becomes 16 minus 38i minus 5 times negative 1 instead of I squared. So that's going to change it to plus 5, because negative 5 times negative 1 is a positive 5. So now finally we'll combine these two like terms, 16 plus 5, which will give me 21 minus the 38i. And this would be the final answer. It's in complex form, complex number form. And there's nothing else we can combine. Okay, number 11, still dealing with complex numbers here. Now we are going to be dividing some complex numbers. So anytime you have a complex number in a fraction like this one, we have 3i in the denominator there. Our goal is to get the complex number out of the denominator. So that's really what it means to divide these complex numbers. We just don't want to have any of the imaginary numbers in the denominator, and we want to write our final answer again in the complex number form. So we want it to have a plus bi. Notice in this form, this is not over anything. It's two separate terms. That's what we want. So we need to take steps to get it rewritten in that form and get the imaginary part out of the denominator. So to do that, we're going to multiply by the conjugate of the denominator. So the conjugate, and it's called complex conjugates. You can also put this on your cheat sheet. Are, if I have a plus bi and a minus bi, these are complex conjugates of each other. So it really just means that the middle term in between them are opposite. So for example, if I had 3 minus 2i, then 3 plus 2i would be conjugates. Complex would be the complex conjugate of the first one. Okay, so that is all just really a definition and an example. You can put the definition of the complex conjugates on your flashcard, just not an example. Okay, so again, like I said, first step to doing these types of problems is to multiply the numerator and the denominator by the complex conjugate of the denominator. Okay, so we're going to multiply the top and bottom of this fraction by the complex conjugate of that denominator. The denominator is 5 plus 3i. So the complex conjugate would be 5 minus 3i. You're just changing the sign in the middle. So that is always step 1. I'm just writing this to the side, but I'm about to actually do it here. Okay, so we're going to take 4i and multiply it by 5 minus 3i. And then we're going to multiply the denominator, 5 plus 3i, by the 5 minus 3i. So you're multiplying the top and the bottom by that complex conjugate. And I'll explain why in a second. I'm just going to move this over here and kind of go this way. Okay, so on the numerator, we're going to distribute this 4i to both terms. So that would be 4i times 5 plus 4i times negative 3i. And on the bottom, we're going to have to FOIL. So first would be 5 times 5, which is 25. Outer would be 5, positive 5 times negative 3i. Inner would be plus 3i times 5. And last would be positive 3i times negative 3i. And then we will go down, so that will give us on top 4 times 5 is 20, so that will give me 20i plus, or actually, sorry, negative, because positive 4i times negative 3i will give me negative 12i squared. Notice on the denominator, these two terms here will cancel because you have negative, once you multiply that, 5 times negative 3 is negative 15. So that'd be negative 15i plus 15i. So those are opposites, they will cancel. So I will bring down the 25 on the denominator. And over here, this will give me negative 9i squared. So now we will replace the I squareds with the -1, because that's what it's equal to. So this will be 20I plus 12, because -12 times -1, I'll just go ahead and write that step out. Okay, and then on the bottom, this would be 25 minus 9 times -1. So that's what I squared is equal to. So I'm just replacing I squared with that. So now we get 20I plus 12 over 25 plus 9. And so now what I'm going to do is I'm going to rewrite the real number 12 in front. So this would be 12 plus 20I and then 25 plus 9 would be 34. And then what we need to do now is separate this into two fractions, because again, remember, we want it to be in this complex number form. So this is going to be 12 over 34 plus 20I over 34. And then, of course, these fractions can be simplified. And so on the first one, they both can be divided by 2. So that would be 6 over 17 plus 10I over 17. So that's me dividing all of those numbers by 2 so that it can be simplified. This would be your final answer. Because you have to have it in complex number form. So now it's in two separate terms. 6 over 17 is a real number, so that's fine. 10I over 17 is the imaginary part, but they are separated. So you just have to keep going on that problem. Okay, so kind of tedious. And again, you can write yourself little reminders on your flashcard as long as you don't put any worked out examples. You can write, to divide complex numbers, multiply the top and the bottom by the conjugate of the denominator, replace I squared with -1, and then separate into two fractions and simplify. You can write notes like that on your flashcard. All right, number 12. Now we are moving into section 2.2. So this one's going to be broken down in steps for you, even on the midterm. So it says, step 1, solve the inequality and express your answer in interval notation. Use decimal form for numerical values. So I'm just going to rewrite this problem, this inequality down here, and we're going to start to solve it. So to solve an inequality, you want to get the variable by itself on one side of the inequality sign, just like with an equation. So I think first I'll just, there's a couple different things you could do, but what I'm going to do first is subtract 9W to cancel it on the right and bring it to the left with that 7W. So 7W minus 9W will give me -2W. Bring down the -1. And now I will add the 1 to move it to the right. And then finally, I have to divide both sides by that -2 to finish getting W by itself. And when you divide both sides of an inequality by a negative, you have to flip the sign. Let me put that there. Okay. So the W will now be by itself, but the greater than or equal to symbol here will now become less than or equal to because I just divided both sides by a negative number. That's always true when you are solving inequalities. If you divide both sides by a negative, you have to flip the sign. And then this would just be -3/2. And this would be the answer in inequality notation. But they want me to write the answer in interval notation. So before I do that, I'm going to graph this on the number line. So -3/2 is -1.5. Which is right 1, 0, -1, right here. That is where -3/2 is. Okay, so this would be a closed circle, like I have it here. Or sometimes they use brackets. I can't remember what Hawks uses. I need to look into that. But it's either going to be a closed circle or it'll be a bracket like this. These denote that it's included. So closed circle. Or bracket. These mean included. It can equal that number. And I know that because of this less than or equal symbol. If it didn't have that straight line under it, it would just be strictly less than. Well, then that would be an open circle or parentheses. So this is when it's not included or can't equal. And the reason why I have the bracket facing to the left is because now we're going to shade everything that W can be, and it says that W can be anything less than or equal to -3/2. So that would be everything to the left. All these numbers are less than. So if I was shading it to the right, the bracket would go this way, but I'm not. And of course, the bracket would be on the number line too, like this, if they wanted you to use the bracket. This would be at -3/2, and then all of this would be shaded. Just get a larger thing here. There we go. All right, now it's kind of easy to see what the interval notation is based on the graph on the number line. Interval notation is built using exactly what you see on the number line. So for the interval notation, you always start from left to right, and because it's going all the way to negative infinity, we're going to start with the parentheses because infinities always get parentheses. And it starts at negative infinity, the shading does. And then you put a comma, and the shading ends at -3/2. And it would be included because it can equal -3/2, so we would end this with a bracket. So that is the interval notation answer that they wanted right here. So there's 3 ways to express the solution of an inequality. In the inequality form, with the inequality symbol, interval notation form, or by graphing it. So all of those mean the same thing. Okay, number 13 says consider the following inequality problem, and we are still in section 2.2. So for this one, we have 2 inequality statements that are separated. So we have -4 times n minus 3 is less than or equal to 20, and 13 plus n is less than 20. So first step wants us to solve the first inequality and express it in interval notation. So let's do that. So I'm assuming the one on the left is the first one. So I'm going to distribute that -4. So that would give me -4n plus 12 is less than or equal to 20. And then I would subtract 12 to both sides. Which would leave me with -4n is less than or equal to 8. And then coming up here, I'm just going to rewrite it real quick. So now I need to divide both sides by that -4. So because I'm dividing both sides of the inequality by a negative, I have to flip the sign. So instead of less than or equal, it'll become greater than or equal, and that will be -2. So I just flipped the sign here because I divided both sides by a negative. Okay, and it wants us to write this one in interval notation, so I'm just going to show you on a number line. If this was -2 here, and I shaded it, I have to shade everything greater than or equal to -2, because that's what it says n can be. N is greater than or equal to -2. So that's going to be shading to the right. And it can equal -2. So that would be a closed circle or a bracket. Use a bracket this time. So an interval notation for this one the shading starts at -2 with a bracket, if I'm reading this from left to right, and then it goes off to positive infinity because it goes all the way to the right forever. So that gets a parentheses. So this is the answer for the first part of for the first part of this problem in step 1. Okay, now we're going to do the same thing for the second inequality. So I'm going to subtract 13 to both sides. So n will be less than 7. And so on a number line, if this was 7, we're shading everything less than 7, and this is strictly less than, so it does not include 7, so that would be a parentheses. shaded to the left, or an open circle. So the way I remember this, if it has a straight line, let me use a color here. If it has a straight line underneath the inequality, then it has a straight bracket. But if it does not, then it gets a parentheses. Okay, and then for the interval notation for this one, it's starting, if I look at that shading from left to right, it's going all the way to negative infinity now. So this would start with a negative infinity with a parentheses and comma, and then it stops at 7 with a parentheses because it's not included. So that's kind of the answer to both of them separately, but they are going to ask us in step 3 now to find the solution to the overall inequality problem, which is this entire thing up here. Now, whenever it has the word or, it means that if it's a solution to the first inequality, then we're going to include it. And if it's a solution to the second inequality, then we're also going to include it. Okay? So because these two solutions overlap, for example, I'm going to write up here on this graph where 7 is. So that first one, it can be anything greater than or equal to -2, so that includes 7. And on the second one, it can be anything less than 7, so that includes -2 and then all the numbers. So these two number lines overlap. So really the solution, since we're including both of them, would be all the numbers. Okay? And I will just show you again separately here. If I had 2 of these, say here is 0, 0, here is 7, and here's -2. So the first one, we said was from -2 bracket all the way to the right. That's what we graphed. Second one was 7, the parentheses, all the way to the left. So notice that if I included both of these answers, it would just be all numbers. So that is what the answer would be. All real numbers. And in interval notation, that would be from -infinity to infinity. That's how you write all real numbers in interval notation, because it starts from left all the way to -infinity and it goes to positive infinity. Now, if that word up here was and, well, then I'm only including the solution that's true for both. So that would actually be where they intersect here. From -2, because it's including -2 in both, up until 7, and it will not include 7 since it's not included in the second problem. So if the word was and instead of or, you would only be doing the intersection. I'm going to erase that so we don't get confused. Okay. All right, moving on. Number 14. So this is going into section 2.5, and this is all about solving rational equations, so equations that have fractions in them and variables in the fraction more specifically. So step 1 is to clear the fractions by multiplying each term. Oops. By the least common denominator. Okay, so before that can happen though, we need to know what the least common denominator is. So, to find the least common denominator, you are going to write down all these denominators. 2x is the first one, 7 is the second one, and then 7x is the third one. And what you're going to do, you're going to look at these three and you're going to write down all the factors in the first denominator, which is 2 and x. So that came from the first denominator. And then you're going to go to the next denominator, and that's 7. So I don't have 7 at all yet, so that will be multiplied by 7. I'm going to include the 7 as well. And then you go to the third one. Well, the third one is 7 and x, and I already have 7 and x here. So I don't need to write that one again because I already have it. So if I multiply these two together, this would be 14x. This is my least common denominator. And this is what I'm going to multiply. Let me use a different color. By every term. So you're finding the smallest thing that all of these denominators can divide into, and that would be 14x. So I have 5 over 2x times 14x minus 8 over 7 times 14x equals 4 over 7x times 14x. So whenever you do this, after you figure out what the least common denominator is, and you can write it like this, where you're multiplying each term in the problem by the 14x, now you're going to divide that 14x by each denominator. So what do I mean by that? So let me get another color. So on the first one, 14x divided by 2x leaves me with 7, because x divided by x cancels. 14 divided by 2 is 7. So what that does is it leaves me with 7 to multiply by what's left in the numerator, which is 5. Okay, so this first one would become 7 times 5. That's what's left. And then the second fraction, 14x divided by 7, leaves me with 2x. Technically negative 2x because of the negative in front of it. 14 divided by 7 is 2. And there's nothing to divide with the x, so the x would stay. So now this is negative 2x times 8. That's left. And then on the last one, we have 14x divided by 7x, which would just be 2. So that would leave us with 2 times 4. So that's why you're trying to find the least common denominator, which is the smallest thing all of those denominators can divide into, so you can cancel your fractions and make your life easier. So 7 times 5 is 35. Negative 2x times 8 would be negative 16x equals 2 times 4 is 8. And then I will subtract 35 to both sides to cancel it there on the left. And that will leave me with negative 27. Just make sure. Yeah, negative 27. And so finally I will divide both sides by negative 16 here. So x will be equal to positive 27 over 16, since negative divided by a negative is positive. And that would be my final answer. You can't simplify that anymore. You do want to be careful that your final answer doesn't make any of these denominators with the x equal to 0, but it will not. The only thing that will make those 0 right now is 0 if x. So if you solve for x and you got x was 0, then it would be no solution, because we cannot have 0 in the denominators of fractions. So you need to watch out for anything that makes the fractions undefined. But that would be the final answer for that problem. Okay, and then the final problem on part 1 is also from 2.5, solving rational equations again. This one's just a little bit more involved. So before we can figure out what the least common denominator is, we need to have everything factored in the denominators. In the last problem, everything was already factored. So z minus 2 is already in a factored form. There's nothing else I can do there. I can't do anything else to z plus 6. But this last one is in quadratic form, so I need to factor that last denominator. So I need two numbers that multiply to give me negative 12. So step 1 is to factor all denominators. So I need two numbers that multiply to give me negative 12, but also add to give me my b, which is 4. So I'm using these two numbers here to get those. I went over that in the first video. And that will be some combination of 6 and 2, and the 2 will have to be negative, because negative 2 plus 6 is positive 4. Negative 2 times 6 is negative 12. So that will factor, let me bring everything else down, z over z minus 2 minus 9 over z plus 6 equals z squared all over z minus 2 times z plus 6. So that is the factored form of that denominator. And we got those numbers from here, the negative 2 and the 6. All right, so now the least common denominator is going to be that z minus 2 times z plus 6, because I have z minus 2 here, I have z plus 6 here, and then I have both of them here. So that is the smallest multiple that all of those will divide into. So that is what I'm going to multiply each term by to clear my fractions. So let me copy this. So I'm multiplying by z minus 2 times z plus 6. On every term. Okay, and then we're going to do that division thing also. That's what you always do after this point. So if it can divide, you divide it and see what's left. So the z minus 2 will divide into that z minus 2, and that will leave me with the z plus 6 times the numerator of z. I'm going to bring this negative symbol here down on the second one, and then z plus 6 and z plus 6 will cancel, and that will leave me with the z minus 2 times 9. And then on the last one, they all will cancel, z minus 2 and the z plus 6, so that'll just leave me with that numerator of z squared. So now we will distribute this z here to both terms. So that'll give me z squared plus 6z. And then here I can distribute the negative to both and the 9. So that'll give me negative 9z plus 18 equals z squared. If I subtract z squared over to both sides, it will cancel, leaving me with 0 on the right. I can combine these two like terms here. I know that kind of looks like a t, but that's a z. 6z minus 9z is negative 3z. Bring down my plus 18. And then subtract the 18 to both sides. So negative 3z is equal to negative 18. Divide by negative 3. So z is equal to a positive 6. You would just want to make sure it doesn't make these denominators equal to 0. 6 minus 2 is 4, so that one's good. And 6 plus 6 is 12, so that's good. And these two will also be fine if you plug it into all of that. So we're good. If that was negative 6, though, it would make this one 0, and we could not include it. So that is the final answer for number 14. Okay, and so that is it for part 1. I will be working on part 2 and hopefully get that posted by tomorrow, which is Monday. I know these videos are kind of lengthy, and that's just because I'm trying to go in as much detail as I can in case you guys didn't understand anything in the text. But just remember, you have to be utilizing those resources as well, reading the text, watching the example videos, scheduling appointments with me, ask me questions. I'm more than willing to help. Please don't wait till last minute. I could literally go into birth at any moment right now. So I don't know how available I will be. I'm trying to get these videos done so you at least have these study guides. So just please email me if you have any questions, and look out for my second video. All right. Have a good night.